Hello everyone. Welcome back to our AWS Certified Solution Architect Associate Bootcamp series. In the last module, we explored AWS Database Services Overview. In this module, we are going to deep dive into Amazon RDS, one of the most important services you will need for both the certification exam and real world scenarios. Let's start with the concept we are going to cover in this module. We'll start with an overview of Amazon RDS and the database engines it supports, why RDS is better than you manage databases on EC2, then what is RDS storage autoscaling and how storage autoscaling helps you avoid downtime. Then we'll review RDS Read Replica feature and how Read Replica improve read scalability. We'll also explore real-world use cases of RDS Read Replicas. Then we'll cover RDS Multi-AZ feature. If you have an existing RDS Single-AZ database, then we'll explain what is the process to convert a single-AZ database into multi-AZ with just few clicks. And finally, we'll look at RDS Custom for workloads like Oracle and SQL Server that need deeper control. If you watch this video without skipping any content, you will get a clear understanding of the RDS concepts you need for your daily task and to pass the AWS Solution Architect Associate certification. Let's get started. Amazon RDS stands for Relational Database Service. It's a fully managed database service that takes away the heavy lifting of database administration. Instead of worrying about backups, patching, upgrades, and replication, which AWS does for you, you can concentrate on your application development. It supports popular database engines like MySQL, PostgreSQL, MariaDB, Oracle, SQL Server, IBM DB2, and Amazon's own proprietary platform, Amazon Aurora. In short, RDS allows you to focus on your application development while AWS handles the database operations. Now let's review the advantages of using Amazon RDS or a managed database service over a self-managed database hosted on Amazon EC2. When you run a database on EC2, you are responsible for everything from scaling, high availability, OS patching to configuring backups and replication. With RDS, AWS takes care of the heavy lifting, starting from automated backups and snapshots, point-in-time recovery, patching and upgrades, monitoring and alerts, and seamless integration with IAM, KMS, and CloudWatch. This means you get higher availability, less operational overhead, and better scalability compared to a self-managed setup. For the AWS certification, please note that Amazon RDS standard does not allow you to SSH into database instance. This is a critical phrase for the AWS certification. If the certification requires you to SSH into database instance, then Amazon RDS standard or Amazon RDS is not the option for you. However, for real-life use cases and most of the AWS certification managed relational database scenarios, RDS is your go-to option. Now let's review Amazon RDS storage autoscaling. If your workload is unpredictable, you can enable storage autoscaling for an Amazon RDS database instance. You can use RDS storage autoscaling to avoid manually scale up your database storage. And here is the option for you. While creating the database, you can enable storage autoscaling, and this is available under additional storage configuration. With storage autoscaling enabled, when Amazon RDS detects that you are running out of free database space, it will automatically scale up for your storage. Amazon RDS starts a storage modification when free available space is less than or equal to 10% of the allocated storage, or the low storage condition lasts for at least 5 minutes, or at least 6 hours have passed since the last storage modification or storage optimization has completed on that instance, and whichever is larger among these three conditions. In terms of incremented storage volume, it will increment either 10 GB or 10% of currently allocated storage, or predicted storage growth exceeding the current allocated storage size in the next 7 hours based on the free storage space matrix, or whichever is larger among these three conditions. While configuring the storage autoscaling, you must configure a maximum storage threshold, and here is the settings. The default value is 1000 GB or 1 terabyte with a minimum of 440 GB and maximum is 65 terabyte. Once the storage has been incremented, you can't reduce the amount of storage for a database instance, and autoscaling can't be used with magnetic storage devices or the EBS with magnetic volume types. Now let's review RDS Read Replica. RDS supports Read Replicas for MySQL, MariaDB, PostgreSQL, Oracle, and SQL Server database engines. Amazon RDS creates a second database instance using a snapshot of the source database instance. It then uses the engine's native asynchronous replication to update the read replica whenever there is a change to the source database instance. Then the read replica operates as a DB instance that allows read-only connections. Please remember, with RDS read replicas, as the name suggests, you cannot direct your write traffic. However, you can only use for read traffic. Amazon RDS for MySQL, PostgreSQL, MariaDB, and SQL Server allow you to add up to 15 read replicas to each database instance, whereas Amazon RDS for Oracle only allow up to 5 read replicas to each database instance. RDS also allows you to create read replica in same availability zone, different availability zone, and also in different AWS region. RDS Read Replica can also be promoted when needed to become a standalone database engine, and this is a manual effort. There is no automation involved here. RDS provides separate URL for master database instance and for each read replica. If you have 5 Amazon RDS read replicas, you will have 5 distinct read URLs or endpoints, one for each read replica. You need to configure read replica endpoints at your application, and you must update the connection string to leverage read replicas. RDS read replicas are not auto-scaled. If your application is sending plethora of requests to one of the read replica, but the second one is idle, then RDS does not auto-scale read traffic between read replicas. For AWS certification, please remember the main purpose of RDS read replica to enhance performance or scalability. This is generally not considered for disaster recovery. However, there is a way for disaster recovery that we are going to discuss in the next slide. And if you want to use read replica for disaster recovery, then please remember you have to manually promote the database. There is no automation involved, or you can add Lambda function to automatically promote. But RDS out of the box does not support automatic promotion. So when should we use read replicas? To start with, first, for reporting and analytics. Instead of running heavy queries on your production database, you can run them on read replica. The second one, for scaling web application. When you have thousands of users browsing, checking availability, or reading data, read replicas will help spread that load. And third, for disaster recovery. A cross-region read replica can serve as a standby copy. And if your primary region goes down, you need to manually promote that read replica, and there is no automatic failover in case of Amazon Read Replica. To summarize, the benefit of Read Replica is your production application will always be unaffected no matter how big your read traffic is. With Amazon Read Replica, as Amazon is replicating the data across your read replicas, there is charge involved. Now let's review the data replication charge. RDS read replica data transfer charges depends on whether the replication occurs within the same AWS region or across different regions. With same AWS region, replication between your source database instance and a read replica in the same AWS region incurs no data transfer charge. And this applies even if the read replica in a different availability zone within the same AWS region. Now let's review read replica across AWS regions. Data replication to read replicas deployed across different AWS regions incurs data transfer charge, and these charges are typically based on the amount of data the database transferred out of the source region. Now let's review Amazon RDS Multi-AZ feature. Multi-AZ deployment provides high availability and durability for database instances by replicating data synchronously to a standby instance in a different availability zone. Now see the difference. For read replica, the synchronization was asynchronous. For multi-AZ, the synchronization is synchronous. In terms of key benefits of RDS multi-AZ, the first one is automatic failover. When Amazon RDS detects an issue with the primary instance or with its availability zone, it automatically initiates a failover to the standby instance. Now let's understand with an example. Let's assume our primary database instance is in USTist 1A and the application is performing read and write operation with the master node placed at USTist 1A. We also have a standby node in USTist 1B. Unlike read replica, this standby will be inactive and can't be used for any transactional operation. Now if disaster strike at USTist 1A or the primary node which is not responding, and maybe because of infrastructure defect such as loss of network connectivity, compute unit failure or storage failure, then RDS will initiate a failover. It will pause all the transaction. Then the standby instance in USTist 1B will be promoted to become the new primary, and then the CNAME or canonical name record of the database endpoint is flipped to point the IP address of the new primary, which was our previous standby, and this process typically takes a short period during which application will see some latency. However, the entire process will be completed without any manual intervention. It's also important to understand the post-disaster scenario. The newly promoted primary instance will remain as primary and it will not be shifted as secondary, which was our previous case. However, the previously failed primary instance is diagnosed by Amazon's internal health monitoring system, and once it's recovered, it will brought back online as the new standby instance on its original availability zone, and it is going to restore synchronous replication between the new primary and the new standby, and which will restore the multi-AZ configuration. This feature will allow your application to connect the database using the same endpoint. The next feature is data synchronization. Data is synchronously replicated from primary instance to the standby instance, which means every transaction is committed to both the instances before being acknowledged to the application. And by this way, it will ensure data consistency and zero data loss during failover. For read replica, there was asynchronous replication. That is why there was a replication lag and you might lose some data, not a very big chunk, but for fraction of seconds. By maintaining a standby replica in a separate availability zone, multi-AZ deployments protect against various failures, including instance failure, storage failure, and availability zone outages. While multi-AZ deployments offer high availability, the synchronous replication can introduce a slight increase with write latency compared to a single AZ deployment, because it is going to make sure the data is persistent in both the instances and then it is going to acknowledge. Currently, we have two multi-AZ options. The first one, the conventional multi-AZ with a single standby in a different availability zone, which will create a primary database instance and a non-readable standby as seen in our example. And then we have a second option, which is a very recent offering by AWS, which provides multi-AZ database clusters with two standbys, which will create a primary database instance with two readable standbys in separate availability zone. For multi-AZ cluster with two standbys, both the standbys come with read capability. That means you can redirect your read traffic to the standby copies. Please remember, multi-AZ with two standby option is only available for MySQL and PostgreSQL database. Now, if you have an existing RDS database with a single AZ configuration, and if you want to convert to a multi-AZ configuration, then how you are going to do that? Now, let's review. To convert a single AZ Amazon RDS instance to a multi-AZ deployment, you can log into AWS Management Console, and there you have the option to modify. Here is a screen print. You can log into AWS Management Console, you can select the database, and you can use this modify option to perform that operation. This is as simple as that. Please remember, it's a zero downtime operation and you don't need to stop your RDS database instance. The database instance status will change to modifying while AWS performs the necessary operation to create the standby instance and establish a synchronous replication. And once the process is completed, then the status will change to available. When you modify the database instance, behind the scene, RDS will create a snapshot of the primary database instance. That means the snapshot of the EVS volume of the primary database. Then RDS will create a new volume for the standby replica from the snapshot. And finally, RDS will turn on synchronous block level replication between the primary and the standby instance. Converting to multi-AZ can lead to elevated latency and performance impact during this conversion process, especially for instances with large storage volume or with a heavy write latency workload. Now let's review the RDS Custom option. Normally when you use Amazon RDS, AWS manages almost everything for you. This is great for most of the applications because you don't have to worry about administration. But sometimes organizations have legacy workload or highly customized databases that need more control than standard RDS allows. And that's where RDS Custom comes in. With RDS Custom, you will get the benefit of AWS managing infrastructure, hardware, failover and backup. But unlike standard RDS, you also get access to the operating system and database environment. That means you can apply custom patches, install third-party software or monitoring agents, or you can configure database settings that normally are not available with RDS. Currently, RDS Custom supports only for Oracle and SQL Server engines because these are the two databases that often have specialized requirement in enterprise environments. And now let's compare standard RDS versus RDS Custom in respect to customers' responsibility. With standard RDS, AWS handles operating system, database, infra. It's a fully managed package. With RDS Custom, AWS handles infra, high availability, backup, but you as a customer should handle operating system and database customization. Now for the AWS certification exam, please remember this. If the question is asking about control and customization for Oracle or SQL Server, then the answer is likely RDS Custom. However, if the focus is on managed service with minimal admin workload is the key, then regular RDS is the right choice for you. That wraps up this module. If you found this video helpful, please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at CloudExpert Solutions. You are now one step closer to crushing your exam. See you in the next module.